around grade 5, we have gotten on top of some arithmetic. We have developed a little bit, and we should be ready for some fractions, some mixed numbers, and so on. Now the concepts are still fairly straightforward, I think, in terms of complexity. Well, let's just randomly pick, I don't know, pick this one. Why not start at the beginning and see what grade 5 fractions can teach us. So again, start with visualization. I like the rectangle. It doesn't have to be a rectangle. But when we start splitting it up, even thirds, but as the number of parts become bigger, I struggle with circles, whereas rectangles are easier to split up. So we have the whole rectangle. That's the basic part of a whole concept of my fraction. One part where I split it into 3. So we're taking our time to just visualize, and then we represent that visualization 1 out of 3 different parts. So that's a third of the rectangle. Very nice. Simple. Good place to start. A good time to start in grade 5. Earlier may be better for some, but if you want to play it safe, grade 5 is early enough. Shade 1 part out of 5 this time. And then we have 1/5. So a very good starting point. The numerator counts how many parts we're selecting or interested in. And the denominator, the bottom one, how many total parts we're splitting the whole rectangle into, even though it's pretty long. I like to draw it a little bit smaller, more compact. If it's too long and big, sometimes kids tend to think like, ooh, this is more than one whole rectangle. And we'll just continue like that. Ooh, 3 selected, so 3 for the top numerator, 4 in total. And we will move on. Okay, so that was a nice introduction, a very good first one to start with. Mixing it up with area models. There's nothing wrong with a rectangle. I really don't have to move on from the rectangle. That's a pretty good place to just live, relax. You can do everything there. But perhaps people want to visualize different things. I still have one whole shape. Square is still pretty simple. Rectangle, that looks very square to me. But okay. And 1 out of 4 parts it's being split into. So that's just a continuation with different shapes.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.
Back to grade 5. I have to amuse myself. Identify fractions is next. Ooh, that's a different shape. I don't have the confidence to draw that shape, I think. Ooh, look at all these shapes. What fraction of the shapes are triangles? Oh, so now the collection. That's a step up maybe in concept. The collection. I have one whole collection. And it consists of different pieces. And I have 1, 2, 3 of those pieces being triangles. How many in total? 1, 2, 3, 4, 5, 6, 7, 8. So it's a variation on the parts of a whole concept. In that, well, not all the parts are exactly the same, but they have the same role in terms of what I'm counting. If I were to count What fraction of the total area is covered by triangles? Well, no, then I can't do it because now the areas are not all the same. So it really depends on what I'm focusing on. I'm focusing on just number of shapes. So each shape is an equivalent part of this collection. But that could definitely be tricky. So I just have shapes. They're all equivalent in the collection. And I'm just focusing on the squares. So there are 2 parts that are squares out of 8. So it does depend on what I'm focusing on. How am I, what? Oh, not squares. This demonstrates that reading is very important. I just read squares and I went with it. I am not immune to being too efficient either, right? Not squares. Obviously, the rest, which is 6. It's so easy to do. You have to check yourself. I have to check myself. I, of course, did that on purpose to illustrate to you how easy it is. I would never personally make a mistake like that, but I wanted to demonstrate it, of course. But you have to really check yourself. What fraction of the shapes are circles or triangles? Okay, good. I'm looking for circles or triangles. 1, 2, 3, 4, 5, 6. Have that property out of the 7 shapes in total. Check yourself. Take the time. There's extra few seconds to not make a silly mistake, as I've demonstrated before, because it happens. No one is immune to it. No one is immune. So we get a slightly modified view or use of the fraction concept, which is very interesting. It depends on what I'm looking for. I'm looking at shapes. I'm looking at number of shapes in the collection, and the role of every shape is the same, and therefore the fraction concept, parts of a whole, still work. Nice. But it's good to see mixing it up. That's nice. I was going to go down this list and see how far we get. Fractions of a whole, word problems. It's a little early, but you know, we visualize the options, so it's not like I'm on my own with the word problem. I have a little bit of help because I can see the options that are visualized, but eventually I might have to make these myself. Estelle's service project is to put a fresh coat of paint on the north wall of the school building. I don't really care about any of that. That's just flavor of the story, right? That's a lot of work. I don't care. So she asks some friends to help. To split up the work, Estelle divides the wall into 8 equal sections. That's all I really care about, right? There's my wall. One wall, 8 equal sections. Which fraction model represents one section of the wall? 1 is selected out of the 8 sections. But also this one. The color is... Can I not select both? Well, both of these are good. Why can't I select both? Which fraction represents one section of the wall? Oh, I need to check that it's split up into 8 sections. The first one is one section of a wall that's split up into 1, 2, 3, 4, 5, 6, 7, 8. Good. Second option is one selected section, but a wall that's split up into 1, 2, 3, 4, 5, 6, 7, 8, 9. So that does not match the story, but the first one does. Again, reading carefully. Reading carefully is key. Oh, it's not a rectangle. That's nice. Now, I don't personally draw circles and split them up because I don't have the drawing skills, but it really doesn't matter which shape you start with. Louis is making a rice pudding for his family. I don't care what kind of pudding it is, but cool. He divides the rice pudding into 2 equal-sized servings. if you can imagine the bowl and you can perfectly split it up and keep them separated, sure. Which fraction model represents one serving of the rice pudding? Well, he splits it up into two. He focuses on one, has to be the middle one. How he's actually going to split them up practically, that's his problem. And we get the idea. Good. Those were good. Let's see what else we got. Fractions of a group word problems. All right. So that sort of goes with sort of the shape list, that even though not all the shapes were equal in certain aspects, if I view them in a certain way, it's just parts of a whole collection. 3 students went to the library together. 2 of them checked out books. What fraction of the students checked out books? So now I have a list or a collection of the 3 students. They're not all the same, but in terms of me counting how many students had a certain property checking out books, they're equal in that sense. So 2 of the 3 checked out books, so 2/3 of that group checked out the books or has that property. So I can modify the fraction concept as long as what I'm focusing on breaks it up into quote-unquote equal parts. Marcy made a bouquet of 3 flowers. It's not very big, but okay. She used 1 pink flower. What fraction of the flowers were pink? Not all the flowers have the same size, but the question doesn't concern size of flowers, just number of flowers, and each part is a single flower and they're equivalent in this concept. I double check, am I actually looking at pink? Yes. So 1 of 3, so 1/3. So fractions can be quite handy. It doesn't have to be looking only at exactly the same things in all aspects and properties. Depends on what I'm looking at. We're carrying on with fractions. Identify fractions on a number line. So the first part here to the what I view as a good introduction to fractions visualizes it with shapes and rectangles and parts of a whole concept. That's sort of the extension of the chip model, or the counters as they like to call it. When we want to think of fractions and being arranged, we can also use the number line, and that could be an alternative, not quite as standalone as it is with integers, but I think it's good to have both and understand the positioning and where these fractions sit relative to each other. So here I could just view this as a rectangle. I could just make a rectangle out of this range from 0 to 1. And I'm breaking up this into smaller pieces, and the proper fractions sit somewhere in here. Now I've split this up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces, and I've moved all the way to cover 10 little sections. So the place where that fraction sits is going to be the fraction 10 over 12. Now, do they ask me to simplify it? I always want to check. They don't ask me to simplify it. So that seems pretty good. Simplification is really an afterthought. It's really always optional. I never have to do it. Very often teachers are obsessed with simplifying, to the point where they send the message that it has to always be done. There was nothing wrong with my 10 over 12 fraction. It was a perfectly good fraction. I don't want to discriminate against non-simplified fractions. They have their place as well. I really don't have to simplify. If the question says I should, okay, then to complete the question I will. Otherwise, I don't really care. It is a skill I should have. Here I'm splitting up into 1, 2, 3, 4, 5, 6, 7, 8 pieces to get 1, right? And we're going all the way to 1, 2, 3, 4, 5, 6, 7. So 7 eighths. Happen to already be simplified? Doesn't matter at all. We get the idea. That's pretty simple. And then I'm guessing they would... Can I go back? Yes. Where am I now? Graph fractions on number lines. Okay. I was expecting some mixed numbers, but that comes later. So this is also proper fractions from 0 to 1. Can I graph one on the number line? It's just the number that you've just stated there is the name of that position as well. That might have been the hardest question ever. Where is 1/8 on the number line listing 1/8? Maybe you shouldn't have listed that, making it a little bit more challenging. There's only one point for 1/8, and it's wherever it is. But I guess highlighting the fact that these are just points on the number line between the integers. That is, I guess, new and important, that fractions are now, by looking at the number line, fractions in my mind is starting to change a little bit from parts of a whole concept to just more numbers, more points on the number line, taking their place among the integers, which is eventually very important. So I've built my number sense, and I've conceptualized the fraction with rectangles and shapes and parts of a collection and all that. Very good. But at some point in the mathematical language, I also want to view them as just more numbers. They're just more points on the number line. That can happen early or later. Doesn't have to be that quick. I don't care rushing that really. All that's left is to get some mixed numbers in here, where I have some wholes as well as some portions of a whole. So here I have these rectangles that are clearly separated by space. I have one whole, 2, 3, 4. So they want me to write it 4 space, and then another portion of a whole, which is 1 selected out of 2 parts. So 4.5. So it is interesting how we're introducing proper fractions for many sections, all proper fractions. Then putting some more whole selections in with the proper fraction selection is not really that big of a step. Is it even a step? I don't know. 2 wholes selected with this partially selected one. Well, that's not a problem. 2 wholes, and my fraction is 2 out of 4 pieces. I don't care if they tell me I'm wrong or right. I don't want to simplify this. That's a follow-up problem if I choose to later. My fraction, my choice. I don't want to simplify everything. That's not a goal that should be a high priority at this stage, in my opinion. And we can keep going like that. But that was a very nice introduction to fractions. Of course, students would need more practice, but this numbers 1 to 8, it's pretty good. I wouldn't care too much about number lines. I would really leave that out of the introduction. Too early can be a little bit messy for people. And then, of course, arithmetic should come much later, and that we'll do at a different time.